Welcome to House Building Digest Series number 8, which is on various aspects about plastering. My name is Dr. Shailesh Kumar Agrawal, Executive Director of BMTPC. Through this digest series, BMTPC is reaching out to common man to provide useful but often ignored information about various essential activities involved in house construction, including technical and non-technical matters associated with building materials and construction technologies. Every individual has a dream of owning a house, and through this series, we will slowly unravel myths and misconceptions about building construction. The language used here is simple so that it is understood by one and all. Let's discuss plastering. Plastering is an element which gives an appreciative appearance to your house, protects it from vagaries of nature, dampness, etc. Accordingly, the home owner should acquaint himself with the process of plastering and carry it out with utmost care. It involves covering of rough surfaces of superstructure walls or underside of ceilings so as to obtain an even, smooth and durable surface. Plastering protects the wall against wind, rain, abrasion, and improves the thermal performance and appearance. Plasters should be easy to apply without the use of expensive and elaborate tools. All types of plasters, proper, especially those on external surfaces, need to offer erosion resistance, impermeability to moisture, impact resistance, and should be well bonded to the wall. Plaster has important requirements in the fresh and hardened states. In the fresh state, plaster must be workable and cohesive. In the hardened state, plaster must be strong enough to hold pain and withstand local impact and abrasion, free of unsightly cracking, well bonded to the base on which it is being applied, should have an acceptable surface texture, should have acceptable surface accuracy with reference to plane or curved surface. There are a number of ways in which plastering can be done in a house. The choice of the type of plastering to be provided is dependent upon the architectural features of the house, local availability of the material, and also the budget of the owner. Thickness of plaster applied is dependent upon the side of the wall being plastered. The plastered thickness on the rough side of the wall is kept more than that on smoother side of the wall. When a mason raises a 9-inch thick or 23 centimeter wall or one brick wall, then the side of the wall on which he works gets a smoother surface, and hence it is called smoother side. Since his hand cannot reach the other side of the wall, a rough surface is obtained, and that side is designated as rough side. Pointing is yet another way of providing protection to the wall, and the process involves application of mortar on the joints of the bricks or stone or block work. There are a number of ways in which pointing can be done on the walls. Usually, pointing works out to be economical than plastering, and accordingly, it is adopted as cost-saving measure. In case of pointing, the bricks block remain exposed to the rain, etc., and accordingly, the performance of the walls is not as good as that of plastered surface. Nowadays, some of the architects advise pointing of inner walls too to give a non-conventional look to the interior of the house. There are many alternatives for providing plaster in a house, and each one has its own distinguishing features. The type of plastering to be provided is also dependent upon its location, whether it is exterior or it is interior or underside of a ceiling. The most common types of plasters in India include mud plaster, lime plaster, gypsum plaster, cement plaster. Let's discuss them one by one. Mud plaster. Provision of mud plaster is an age-old method for protecting the walls, and the practice is found in almost all parts of the world. Mud plasters can practically be used for any surface, including mud or burnt bricks, stones, etc. Plasters out of mud are usually adopted in village houses as they are made out of local material, employing local masons and local artisans, and are also proved to be economical. Thermally, mud plasters are more comfortable than other types of plasters. Let's understand how to make mud plaster. Mud plasters often use earth in combination with other natural materials such as wheat straw or cow dung or bhusa. Additive like bitumen improve the basic qualities of the mud as they act as stabilizers, hardeners, and provide waterproofing properties. Even without additives, mud plasters give excellent results provided that they are made and applied with skill and great care and maintained regularly. Let me just tell you the composition of mud plaster. It varies from place to place and is an important factor in determining its durability. If the clay content is too low, the plaster will lack strength and cohesion, and if it is too high, there will be risk of cracking due to mixing of mud plaster shrinkage. A suitable clay content is usually around 10 to 15%, but values outside this range could also be suitable depending upon the type of clay you are using. The sand to silt ratio is also very important in determining the quality of plaster. The amount of fibers required will also vary depending upon the soil characteristics, and requirements can vary from place to place. Typically, paddy straw, which is also known as bhusa, is added at a rate of 6% by weight of mud. Mud plaster can be applied in two coats. The first coat may be thicker, containing more clay, while the second coat, which may be thinner, may contain more sand. The second coat is usually applied in a thinner layer. The second coat helps to close the micro cracks in the first layer, provided the surface has been lightly dampened before plastering. Finally, whitewash can be applied to give some additional weatherproofing. If a cement or lime stabilizer is mixed in the mud, the plaster surface should be sprayed with water at least 2 or 3 times a day during the initial period to reduce the development of cracks. In general, plaster work should be shaded from the sun, and plastering work should be avoided on hot and windy days. In all cases, it is advisable to try out different mixes to find which one gives the best results with a given soil. There is another type of mud plaster which is known as wattle and daub walls. Daub is yet another form of wall finish which is made from mud, animal dung, and straw. If the It is applied to a structure of wattle or slim interwoven lengths of wood, as shown in this picture on your right hand side. Let's move to lime plaster. Lime plaster, as you can see here, plastering of wall surfaces with lime as a binder has been in vogue historically since ages. The lime to be used can either be fat or it can be hydraulic. Fat lime is said to make a good plaster as it makes good putty after slaking. On the other hand, hydraulic lime makes a strong and hard plaster, although it contains some unslaked particles. They may slake over a period of time, displaying blisters on the plastered surface. Let me tell you the advantages of lime plasters. It has light reflecting qualities, creating unique aesthetics. It has the quality of absorbing moisture and can regulate temperatures, keeping warm in winter and cool in summer, and uh, balance humidity levels. It has good weatherproof properties. Use of hydraulic and non-hydraulic lime creates good water resistant properties. The constituents of lime plasters are as given here: lime and fine aggregates. Let's discuss them one by one. Normally, two types of lime are available in the market. One is quick lime and another one is hydraulic lime. Quick lime, also known as non-hydraulic lime, is supplied in the form of lumps and is slaked by addition of water and converted into lime putty before use. Slaking is done in large tanks where water is added to convert the quick lime to hydrated lime. On the other hand, hydraulic lime is available in the form of dry powder and is normally supplied in jute bags having a waterproofing membrane. The bags have markings indicating the class of lime, date of manufacture, etc. Due to delays involved in slaking process of quick lime, hydrated lime is mostly used in construction. Normally, hydrated lime is converted into lime putty by soaking it for at least 16 hours. Lime of whichever form is to be used, it has to be stored in weatherproof sheds as it can be damaged by moisture and air slaking. Now let's discuss uh, uh, fine aggregates. For the purpose of preparation of mortar for lime plaster, fine aggregates are to be added to lime. The fine aggregates can be in the form of natural sand, crushed stone sand, stone dust, marble dust, fly ash, or surki. The aggregates should be hard, durable, chemically inert, and free from organic impurities. The silt content, always remember, in the fine aggregate should be within prescribed limits. In case the silt content is higher, the fine aggregate should be washed properly till the desired levels are achieved. The proportions of various materials to be used for making lime mortar depend upon the properties of lime and the requirements of strength. Lime mortars for plastering can be made adding the aggregates in various proportions depending upon the requirement and local availability of materials. Typical proportions by volume, which are commonly used, uh, 1 is to 1 is to 6, where 1 is cement, 1 is lime, and 6 is sand. 1 is to 2 is to 9, where 1 is cement, 2 is hydraulic lime, and 9 is sand. 1 is to 2, where 1 is lime, 1 is pozzolana, and 2 parts of sand. 1 is to 2 is to 8, when surki is to be used. 1 is cement, 2 is lime, and 8 is surki. There are a number of ways in which different materials can be mixed for mortars for the purpose of plastering. Most commonly, to mix cement lime plaster, the cement, lime, and sand are mixed dry in the required proportions. More often, the lime and sand are mixed together first, followed by addition of cement. Then, water is mixed in sufficient or required quantity to give it desired consistency. The mix so obtained should be used for plastering within the specified time after mixing. Partly set mortar should not be used for plastering. The thickness of lime plaster may be 12 mm, 15 mm, or 18 mm. The 12 mm thickness is applied on the smooth side of the wall. Remember, I explained you what is smooth side and rough side of the wall, whereas 15 mm thickness is applied on the rough side. The 18 mm plaster is applied always in two coats, the first being 12 mm thick and the second coat being 6 mm thick. Curing of the plastered surface should commence after 24 hours of its application and should be carried out up to 7 days depending upon the climatic conditions. The house owners are advised to consult the architect and engineer for finalization of the specification and type of lime and proportions of other materials to be used in plastering. Let's move to next kind of plaster, that is plaster of Paris, or known as gypsum plaster. Research has shown that gypsum in conjunction with lime has been in use since 16th century for flooring, walling and ceiling, although gypsum was mixed in small quantities only. Over the last 200 years, gypsum has been predominantly used for casting decorative elements. Gypsum plaster requires small proportions of sand and other aggregates and sets with little change in volume and with negligible shrinkage uh, on drying. It is light in weight, thus ideally suited for use in multi-storied buildings. The plaster can be used with ease and without any waste. Since it dries up quickly, The finishing coat can be applied immediately after the undercoat has set, usually the same day. Gypsum plaster should not be used in humid areas or for external work, as it has inherent affinity of absorbing dampness or moisture. Further, bags containing gypsum plaster should not be kept in humid surroundings for longer periods, as it absorbs moisture from the atmosphere. Prolonged storage hastens the rate of setting, leading to reduction of strength of set plaster. Storage for 3 months of gypsum plaster, even in dry place, results in its deterioration. Now let's move to the most common plaster being used, which is cement plaster or Portland cement plaster, also known as stucco. It is an excellent plaster for all the locations. It is strong and durable and can be finished in a wide range of colors and textures. Cement can be mixed with fine or coarse sand, although other materials like lime, fly ash can also be added in different proportions to get the mortar for plaster. The water to cement ratio is very critical for such type of plasters. The main materials for preparation of cement mortar for plaster works are cement and aggregates. Let's discuss them one by one. Normally, 43 grade cement is used for construction of building and houses. The cement is usually supplied in bags of approved quality, which should have the name of manufacturer, date of manufacture, grade and type of cement. Cement brought to the site should not be more than 6 weeks old from the date of manufacture. Fine aggregates is an aggregate which passes through 4.75 mm ISC. It can consist of natural sand or crushed stone or sandstone dust or marble dust. The aggregate should be hard and durable and should not have more than the specified amount of organic impurities or silt or harmful chemicals. Sand is by far the major constituent of a plaster mix and has a significant influence on its performance and cost. In a plaster, water performs two functions. Water is very important. First, it transforms the dry ingredients into a plastic workable mix. Second, it combines with the binder to induce hardening. A fixed quantity of water per unit of cement is required for complete hydration, and the water cement ratio as desired should be maintained in the mortar mix. Excess over this amount will reduce the plaster strength. The water to be used should be potable, that means drinking water, and should contain no dissolved chemicals that might accelerate or retard the setting time. The amount of water to be added for workability depends on several factors such as characteristics and age of the binder, application method, drying condition, and the tendency of the base to absorb water. Let's look at the mixed proportions of cement plaster mortar. Cement and sand mortars for plastering can be in the ratio of 1:3, 1:4, or 1:6 by volume. The ratio representing cement is to sand. The sand to be used, as I explained you earlier, can either be fine or coarse depending upon the construction specifications prepared by architect and engineer. However, if lime is to be added in the mix, the proportion may be 1:2:9, where 1 is cement, 2 is lime, and 9 is sand. In case stone dust is being used, the proportion can be 1:2, where 1 is cement and 2 is stone dust. Cement plaster can be mixed either by hand or by using a machine. Hand mixing is usually done when quantum of plastering is limited, say in case of a house, whereas machine mixing uh, is used when quantum of mortar is of higher mortar. In hand mixing, the dry ingredients, that is cement cement and aggregates are thoroughly blended in the dry state in required quantities, preferably on a plain GI or other such sheet or board. A pile of dry ingredients is made and an inverted cone is made in the middle as shown in this picture, and water is poured into the cone. The mixing is commenced by pulling the dry material into the water. Mixing is continued until the materials have been thoroughly blended and proper consistency has been attained. Mixing should not be continued for more than 10 to 15 minutes after the materials have been thoroughly blended. For the quicker, more thorough mix, a plaster mixing machine is used. In this case, the water is added in the first instance, followed by adding half quantity of sand, cement, and any admixture desired is then added, followed by remaining quantity of sand. Mixing takes place either by rotation of drum or by rotation of the blades inside the drum. The drum is tilted to discharge plaster into a wheelbarrow or other container. The batch is mixed until it is uniform and attain a proper consistency. Usually 3 to 4 minutes of mixing is sufficient for achieving the desired results. In either case, whether it is hand mixing or machine mixing, the plaster must be used within 2 hours of mixing, and no set plaster should be remixed with water and used. The building surfaces to be plastered must be clean. They should be free from paint, oil, dust, etc., if any, before commencement of plastering. It is always advisable that on brick and block building walls, they are to be raked out from the joints by about 1.5 inches to provide a mechanical key. Joint should be raked while the mortar is still soft. Thickness of plaster to be applied depends upon surface being plastered. For example, if plaster is being done on a half brick wall which has a smooth surface on both sides, a 12 mm thickness may be sufficient. On the other hand, on a 23 centimeter or 9-inch brick wall, the smooth side can have 12 mm thick plaster, and the rough side can have 15 mm thickness or so. Plastering on the underside of ceiling is usually done in 6 mm thickness. After the plaster has been applied and finished, it is essential to protect it from the sun and wind by covering it with a plastic sheet and keeping it moist for at least 7 days. Uh, uh, in order to have good plastering practice, the following procedure will help. Uh, Number one, the constituents of plaster, say cement, lime, sand, etc., should be available in adequate quantity to finish the day's job. It may be remembered that lime needs soaking, clay needs to be screened, and straw needs to be shredded, and the like. The area to be plastered should be planned in advance. It is advisable to plaster a full section of the wall in a session. It is also advisable to keep the surface being plastered in shade to avoid cracking on the plastered surface. If possible, the surface being plastered should not be exposed to direct sunlight. The sand to be used in plastering should be kept dry in order to achieve good results. The tools for plastering should be absolutely clean before commencement of plastering work. If plastering onto masonry or brickwork, a stiff brush should be used to remove any dust or loose debris. As a guide for thickness and a flatness, small plastered surf patches may be applied on the wall at intervals of 3 feet to 4 feet. While plastering the wall, work from the bottom left-hand corner upwards, filling a complete vertical section should be done. As each section between plaster patch is completed, run the straight edge from bottom upwards in a left to right uh, uh, sign motion to level it off. After about 20 minutes, run a clean float over the wall to remove any marks and flatten it to a smooth finish. On the final layer of a plaster, that is after flattening and a further 30 to 40 minutes, splash the wall with a little clean water using the brush and then run a clean float over it. The water acts as a lubricant to allow the trowel to run over the surface, picking up any loose particles and depositing them in any tiny holes. This produces a silky, smooth finish. At last, plastering is a tricky trade to master and need to be practiced uh, to make it perfect. A good quality plaster finish is the result of managing the tools and materials in response to the changing condition of plaster that is being applied. Plastering walls and plastering ceilings are important jobs and have to be done with great cares. Most professionals recommend that each layer of plastering to be done in two applications to achieve good results. The second layer of plaster has to be applied when the first has got stiff but not dry. Experienced plasterers are of the opinion that it costs 3 times as much to replaster a terrible surface as it does to get it right for the first time. So always do the plaster with great care. I hope this Building Digest number 8 will be helpful for creating awareness about the construction of a house, and it can be downloaded from our website www.bmtpc.org. The next topic to be covered will be painting. Thank you very much.